So I'm going to talk about some DNS measurements that I did at the F-Root server in Palo Alto. Yes? Like this guy? Does that work? Is that better? Okay. These measurements were mostly done in January of 2001 when we were trying to collect data and sneak a measurement paper into SIGCOMM. We failed with that, but we still got some cool data. And so I'm going to tell you a little bit about DNS. You guys all know about DNS, but I've given this talk other places where they don't. We have 13 root servers, and the roots are now serving only the true top-level domains and inatter, a little bit of inatter, and edu. They used to serve ComNet and org and were very busy then. Those have been separated out into separate servers. The query rates at the roots, it turns out that A root is the most busy thanks to Microsoft. Their first query for a root server always goes to A, never round robins, never lets any of the smarts in DNS that help with load balancing get a chance to kick in. It's hardwired into their code. At the other root servers, I think F is typical. F is quite well connected, and bind tries to go to the closest server from the point of view of round trip time. So the rates we see at F are about 5,000 queries a second. During a recent, and not too recent now, DOS attack on A, the query rate they saw was 38,000 queries a second. That was sustained for a very short period of time. It totally saturated the incoming bandwidth, and it may have been someone testing an attack for later use. This slide sort of shows you the location of the roots. There are a couple of errors in this, but this was the most readable version I had. London and Amsterdam are interchanged with respect to whether they have a root or a GPLD server. You'll notice that 6 root servers are in the Washington, D.C. area. That's not too well geographically dispersed around the world. Only 3 root servers are outside the U.S. ICANN may fix this, but it isn't really broken in the sense that root servers are not working well. The operators of root servers are very clueful folks. A root server basically never answers your question. You can ask for the IP address of something or other, yahoo.com, and it's going to give you a referral to a server that knows the address. So root servers typically answer with referrals. A referral just says, don't ask me, I'm too busy, go ask this other guy, he really knows. This is the query process, and local configuration can change that a little bit. You locally can configure things to not go ask a root, but ask a forwarder at your local site first. Many sites do that because each time a DNS query is made, the local server adds an entry to their cache and knows the answer, which is saved for the amount of time that the TTL of the record specifies. There's been a lot of talk lately of meddling with bind and making the TTLs very short and having bind interact with load balancing things, and these all kind of break things. Don't do that. The measurements that we did were at F. F is a pair of DEC alphas load balanced behind a Cisco router running Ceph for load balancing. Each is a dual processor machine, but they're running bind 8 code, which is single threaded. So one processor was for me to use for my measurements, and the other processor continued to answer queries and do the right stuff. We used netstat for a period of 2 weeks to get the query load, and we used TCP dump to gather traces, and then used a wonderful Perl script that Paul Vixie wrote that basically sorted all those queries into piles of bogus folks and labeled the bogus ones first. The TCP dump line that I used gathered 600 bytes of data, so I had the whole query, typically a 512 byte packet. This is the query rate, and what I've plotted here is one of the F routes on the top half and the other one on the bottom in negative values. So the load balancing clearly works. Those curves are pretty symmetric. You see some big spikes there, and those are times when I copied the data file from one root server to the other, so it became input for one and output for the other. The lines are also a little fuzzy, and what I've tried to plot here and doesn't show very well is the number of queries coming in and then the number of answers going back out to see if F was dropping any queries or to see exactly what was going on. We do see a difference in those two, but it's not because of F dropping queries, it's more because of someone asking for the host name associated with a net 10 address, for example, and something that's unanswerable. We saw about, let's see, it's 7% of the queries involving RFC 1918 space. This is the private address space that should never, questions about that should never leave your local network, and yet they're leaking out onto the internet. Those queries are normally filtered at the F root and the DNS never sees them, but Paul Vixie turned off his filters for my measurements so we could see exactly how bad they were. And you see about 4% of the queries arriving that just absolutely can't be answered because they're from a 1918 address, in which case there's no route back to them, or they're asking a question about a 1918 address for which there's no answer. We also saw some other kinds of errors. Source port 0 is illegal, and US West has a sysadmin who loves source port 0. So about 90% of the source port 0 things that I see are from either Quest or US West. DNS is so robust that they don't notice that many of their name servers are totally ineffective. Windows, some implementations of Windows have a byte order problem where the DNS query header has an integer field, a 16-bit field, that tells how many queries are in the packet, and the only real possible value there is a 1. But if you have a byte order problem and you didn't call that function you're supposed to, 1 will show up as 256, and then that gets dropped because there aren't 256 queries there. The other big error thing that I see is people trying to dynamically update the root zone. Now, it's fine to have your DHCP server try to dynamically update your name server, but it's not okay to go out and try to update COM and DOT and things like that. And guess who's guilty there? Microsoft Win2K, and we'll see exactly when it was released and how bad it is in some graphs of the syslog data. If we look at the query types in this data, we're seeing that most of the queries are for either A records or pointer records. There are a lot of bogus queries for unknown types, and they come from many different servers. It's not just a single server that's broken. It's spread across the realm. In unreadable type here is the measurement regime I did. I started with trying to do an hour-long query. I did one 2-hour-long one. I tried to do a full day and didn't have enough disk space, and probably would have had trouble doing things like copying 35-gigabyte files across the local network. It's a little scary to fill up a root server's disk, and I only have a login on this machine because I am very careful and don't make that kind of mistake. I tried to copy the files off to another machine that had plenty of disk, but NFS told me. So basically I measured short samples, 1 million queries or 2 million queries, and then the distribution of error types that I saw was pretty representative. So I kind of am hand-waving the claim that the short files are representative, and I can use those to draw conclusions. This is the Perl script and the output from it. That first line says that the host at 202.204.32.111 asked for the IP address of fs.dai.net 365,326 times in 2 minutes. Something's wrong there, for sure. The worst offender were 2 mill hosts. They accounted, in 1 hour-long trace, they accounted for 9% of the queries arriving at the F-root. And they were asking the same question over and over again. The question was about the host name associated with a particular IP address, and the roots answered very politely and gave them a referral to the right server to ask for that question. That particular server was down, and so they got serve fail returned, and then they asked the question again. In this particular instance, I noticed that they were asking the question twice or 3 times with the same timestamp. It turns out that the DEC kernel has a millisecond time granularity unless you compile with special microsecond option, and so that's what I was seeing. Within the same millisecond, these guys were asking the same question multiple times. We recompiled the kernel, and that spread them out a little bit in the log file, but not in time. These are just totally broken hosts. I took the top, I don't know, I guess top 37 repeat offenders. These are name servers that always are asking the same bogus question over and over and over again. And I ran Nmap on them, and about a third of them were down, a third of them were Microsoft servers, and the others found 1 Solaris box, or 5 Solaris boxes and 1 IBM box. Who's doing all these repeat queries? If we look at the trace files, the 4-minute trace, within that 4 minutes, 62% of the queries are repeated. Same server asking same question. What happened to caching in TTL? In a 2-hour sample, it's 85%. Now, maybe in 2 hours you might need to ask the same question again, but not in 4 minutes. I started to take a look at the kind of errors, kind of packets that were going there, going to the root servers. And one thing that I saw that seemed really bad was that people were asking for an IP address, and the host name they were giving was already an IP address. So they were asking for an IP address in top-level domain 53 or 29 or whatever the last byte of the IP address was. And that goes to the root. And the root server was patiently answering no such domain, and no one was caching that, and they were asking the same thing again and again. This turns out to be a bug in the Microsoft resolvers, and it was fixed for Win2K in Service Pack 2. I thought that I might be able to track the adoption rates of Service Pack 2, but it doesn't seem to be true. I saw it decreasing for a while, but now it's back up again. 14% of the queries arriving at the root are this bogus thing. Mac OS does it too, and Mac OS, if you have Mac OS, there's a daemon called lookupd, which is their own solution. They also run bind, and bind does it right. But if you kill lookupd, you'll have the same functionality and you won't do it wrong. This is a case where whoever wrote this software, in the Win2K case, it's a missing else statement. It's something like, if I already know the answer, tell the user, Missing else, go ask the network. And they aren't even sending the network the proper question, they're sending the network the answer. It's very hard to get these things fixed. When you find the right person within a company, it gets fixed right away. But finding the right person is hard. And it's hard to track them down because you don't see back to the Win2K box that actually asked the question. You see back to the campus name server or the company name server that's often a Unix box. And it's just passing along the query from the client. I looked at the queries that were arriving that got no such domain. Now that happens if you make a typo. If you spell the name of a top-level domain wrong, you're going to query the root and you're going to get back no such domain. But these names are not typos. Localhost, loghost, HP network printers, and then a whole bunch that are Microsoft Active Directory names. Microsoft Active Directory stuff is leaking out onto the internet, perhaps not due to bugs in the software, but due to bugs in the documentation or the defaults when it gets installed. And this is 20% of the queries at these root servers. Now, 14% of those bogus A queries. You can kind of tell I don't like Microsoft's DNS implementation. When we look at private address space, this set of addresses, net 10, some 172 addresses and 192.168 addresses, are for internal use and have no meaning on the global internet. And they should never sneak out. How is this happening? People do split DNS and don't have it configured quite right. I don't know how it's happening other than just misconfiguration at local sites. We have a wealth of information in the syslog data kept at F. I have over 2 years worth of syslog files. And the two kinds of errors that I see consistently are source port 0 packets and updates. It's fine to update your local zone. It's not so cool to try to update the root zone. This graph shows the counts of those packets. The top graph that's kind of wiggling around up here, and I guess the mouse shows, this is the source port 0. And then this bottom, more subtle graph is the dynamic updates applied to the root zone. So I would say it was about August of 2000 that Win2K got released. And it got, or no, maybe over here, May probably. By August it got adopted quite a bit. And you can see the level of update packets that are sent. These spikes on the source port 0, I didn't understand. I looked up quite a few things and saw that it was often US West or Quest that was broken. I haven't been able to find a sysadmin there to get it fixed. Then I looked in detail at a spike. This is April of 2001, and this is just a huge number relative to the background noise of that black line that's way down there at the bottom. This one turns out not to be an attack. I thought at first it was an attack, but it's not. You're probably familiar with the log files that say some sort of error message, and then they say last message repeated 2 times or 10 times or 30 times. In this particular time, this is April 23rd, we're seeing the last message repeated thousands of times. A dig to trying to find out who this host is fails, but it returns no such domain, but it does point to APNIC. Who is there shows a Hong Kong ISP, and Nmap doesn't tell me what kind of system it was. But this kind of thing is probably responsible for those giant spikes in my data. And then the background level of source port 0 is just misconfiguration. Bind allows you to specify the source port so that you can filter with your firewall and know that it's your DNS server who's doing something. By default, Bind just uses a high-numbered port as the source port. Lots of people configure it to use port 53 as the source port. And sysadmins should never use 0, but some do. This table, which probably is unreadable, is kind of summarizing all of the errors that I saw. A couple of columns to look at. Here is this bogus A queries that I think I've gotten fixed. So I should see that column decreasing. This is the bogus TLDs, and it's well above 20%. So this is a combination of these bogus A queries and Microsoft Active Directory names leaking out onto the internet. Now we talk about making the root servers faster, but when 25% of their load is just bogus things from broken clients, maybe we should fix the broken clients. This last column is documenting how often or what percentage of the queries were the same name server asking the same question more than once a minute, which seems to me like it shouldn't really happen if caching is working and TTLs are set to sensible values. And we see in longer traces it's 50%, and in shorter traces it's more like 25%. Down toward the bottom I have a couple of more recent values, March, July, September 11th, and November, and I did a measurement this morning. I thought from these numbers that I was seeing Service Pack 2 get installed and seeing the number of bogus A queries go down from the high 14s to 13.5 to 13, but today's data showed it back up at 14.8, so I don't have enough data to draw conclusions there. During the measurement period, there were two kinds of attacks on the F-root that I saw. One was using the root servers as a reflector and targeting a register.com client. So the source address was forged, and they were just asking for the address of the root servers individually and doing it very often. The other one that I saw is more interesting, perhaps. This is someone just trolling for host names, I assume. They're asking for the reverse record, so they want a host name. The 54 is a parameter. I saw other instances where it was another value. The person doing this or writing the software didn't understand that IP addresses in pointer queries get reversed. And so they're changing the last byte of the IP address when probably they intended to change the first byte and be able to scan a particular network. These are randomly generated. This increased the query load quite a bit. There was a day when Microsoft broke their DNS totally, January 24th, I think it was. They had their DNS very robustly designed. They put all of their servers behind the same router on a single subnet, which DNS 101 tells you never to do. They had their TTL set to 2 hours, and so after 2 hours they started, what happened is the router got misconfigured, and so it was blocking traffic to their servers. Traffic could not get through to their servers. As the TTL timed out in people's caches, they were coming to the root servers. And the Microsoft query load for just Microsoft names, not just Microsoft.com, but MSN and all the Microsoft properties, became 25% of the load at F during that time while their DNS was broken. So a single highly visible site can affect the infrastructure. I looked also on September 11th at CNN to see how they were affected and how they affected the routes. The query load was higher than normal for CNN.com, but nowhere near, not even a percent, not negligibly higher. So you could see that people were going from telephones which didn't work into New York City to trying to find out information on the net. But they had a robust DNS design and sensible TTLs. And their servers failed from load. They just melted down. Their pages were way too complicated and things. And it took them a couple of hours to recover, but DNS was never the culprit there or guilty. So in conclusion, we have lots of bogus queries out there. I guess the most disturbing are these bogus A queries, which is just a software error. It's very hard to get everything fixed. I can't find, if any of you know who is responsible for DNS at Microsoft on things like WinNT and Win95 and 98, I need some contact info there. I have the right person for Win2K, and hopefully the same bug did not appear in WinXP. Maybe it did. Maybe that's why it's going back up again. And I've gotten to the Mac people. Let's see. Negative caching could really help. And Microsoft, I think, in Win2K is the first implementation of negative caching. Microsoft also totally doesn't follow the rules. They do a query to the A route, and if it isn't answering within a second or so, they do parallel queries to all the others simultaneously. So if any of you would need a job in DNS, go work for Microsoft. Fix it. One of the things that surprised me, and I understand it, is the testing. You test if your code works right in the positive sense. I do a query, did I get the answer back? But you never test to see if you put other junk on the network. And that kind of testing is not taught in our universities. I know I never taught it in my classes, and I was pretty anal about teaching testing. So I think the idea of testing your software for negative behavior as well as positive behavior. You know what it's supposed to do, make sure it does what it's supposed to do, but also make sure it doesn't do what it isn't supposed to do. Okay, any questions? Did I finish in time?
I have not so much a question as a clarification. So, so that everyone knows, Evie is a member of ISC's board of directors. She can have an account on F even if she fills the disk.
I can have an account on F even if I fill the disk.
I had a comment, not really a question, since everyone seems to be involved in this Microsoft love fest, which is that when I arrived at Akamai, I was told that I could have the job if I could solve the Gomez syndrome. The Gomez syndrome was that Gomez, who was at the time not a customer, although they are now, was coming to Akamai servers. People who wanted to get Gomez content were coming to Akamai servers, and people said, you evil people are stealing the DNS. And so we actually get tens of millions of requests per day at the HTTP level against our servers that have nothing to do with Akamai customers. And after about a year, we trace this down to a Microsoft bug where they have cache corruption in how they store their DNS entries. But it's actually quite interesting, and we have this very innocuous weberrors.com that people get pointed to, so they don't say, you evil people are stealing our DNS. But we've had great difficulty getting anyone to even acknowledge this as a problem that needs to be fixed, even though Microsoft is a customer. So we found this to be difficult.
I used my IETF contacts to get to Microsoft engineers and got very good response on fixing the Win2K resolver problem. So I think if you can get to the right people, it does work.